Yeah, draft physics video. Yeah, I think I put the camera down for a little while. Before I get to the something that requires uh, modeling, they'll call it drawing or something. So anyway, lots of subjects. Been watching some videos of the crank, new guy, whatever it's called again. Oh, you dissonant science. Yeah. Anyway. Um, yeah. So he's sort of got a personality. I mean, he's not an easy guy to hate, where some of these other people are becoming easy to hate. So anyway, and then, yeah, I'll talk a little bit about his stuff, and then Ken Wheeler made a video where he's doing the scalar wave thing, and Tesla, uh, crazy. So maybe I'll play some of that because it's anyway. He's arguing that there is this instantaneous communication because you don't use a regular wave that's waving. You just use the straight part of the wave or something, and you know, so you just send electricity places somehow efficiently. He's even brought up like this idea where you charge your phone based on radio frequency, and anybody who's got any brains has got to know that's got to be fairly inefficient. You're collecting a small percentage of the energy being put out into the room to charge your phone. I mean, it's a nice gimmick, but it's not in any kind of people keep blending this stuff into like some sort of efficiency. It's like the whole idea of electric cars being efficient fundamentally, when yeah, they're efficient if they're light and small, but they're not very efficient in any other, except for smog problems in some kind of local area. Otherwise, it's still the same energy equation, and in a way, you're wasting a lot of energy because of the inefficiencies of the batteries and the heat created and the transmission of the electricity to the car. All of that. It's not exactly green, but people just keep arguing as if it is a miracle. So anyway, well, I guess I'll just read this Holiday comment. Fortuitous blunder, do they call it? Oh, the other crank, LOL. He is just trying to sell his Mummies documentary at his website. Yeah, so yeah, that is kind of a strike against somebody who's talking about dissident science and all that kind of stuff when you don't really publish your science. You're selling it. It's sort of a, yeah, I mean, that's a strike against you in my opinion. It's not a very scientific approach. Force people to buy it. I'm going to buy the truth. Um, anyway, that's why he doesn't give any details in his videos, just another Ken. Well, I don't think he's another Ken in the sense that Ken doesn't have any details. So, I read Ken's book and it won't do you any good. I mean, it's the same as his videos. I mean, it doesn't tell you anything. Lots of hyperboloids and drawings, but nothing that explains how anything actually physically works. Just that it does using these moving parts, and you wonder where they get the energy to do all this moving all the time. So that's a subject I wanted to get to is magnets, and the idea of, it's even that homo motory thing, the idea that there's some sort of movement in matter, in magnets. And I think people have the wrong idea. The fields only move in how they interact with each other, but there's no moving parts in the magnet, so to speak. See, every time you say something that sounds like an absolute statement, you have to be so careful because you're like, no, well, I'm not saying that the molecules don't move at all. I'm just saying there's no swirling fields, moving fields. See, I often talk about electricity, and they talk about well, see, this is where it gets eddy currents is appropriate because those are currents. But they always, they often talk about the the current going one way and the voltage another way, and this, and it just gets, they create too many moving parts. You just got to follow the electrons when it comes to electricity, because they'll tell you where the force is going. But anyway, I don't want to get into it. That wasn't the subject that I intended to get to. The real subject is really lensing. I'm curious. So through, jumping through these different things. So from the dissident science guy, I ended up at the Thunderbolts project, and Dr. Edward Dowd, solar. So I'll leave a link. Solar gravitation, a wave propagation on interaction. All right, so it's not a brilliantly articulate title. And the guy does have too southern an accent, so I'm sure the foreigners won't understand what the fuck he's saying. But anyway, a couple of the points raised are, I think, really valid points. And I'm not exactly sure about what he has. It's not that he's reinterpreted Einstein's equations, but he's re-derived them and then used jeez, words. I can't remember the name of it, but the thing from Maxwell, where you put the Gaussian surface around something and blah blah blah, and that's all for charges and stuff. I don't think gravity is quite the same as a charge field, so I don't think so. It just has to do with how big this field of gravity would be, how strong the gravity has to be to bend light, how long the light is in the gravity, and how strong the gravity is going to decide this question of how much you can bend the photon. So his fundamental argument is that the sun's corona has created whatever lensing effects that have been detected through experiments with radiation that's coming from the universe, let's say the background radiation, I don't know if they've done it with that, but other forms of radiation, and they get some bending. And I've seen some of the data on those experiments, and yeah, the problem is it doesn't have any trailing off. Like the lensing should get weaker and weaker and weaker, and it just kind of stops. Kind of like the idea of the corona would stop much quicker than the field of lensing should. So you'd end up with where it would just drift, like things would be lensed and then there'd be a little tiny bit of lensing, a little tiny bit. So there's no gradation. It just kind of ends, implying that it's the stuff in the stuff in the atmosphere around the sun. There's lots of charged particles, and they're deflecting the light, scattering it, and I'd argue that should be detectable because you should always see a weakness in the signal if it's just scatter. But then again, it could be an organized scatter, in the sense that it would also be logical to think if these are charged particles in the corona, that they would be forming field lines also. There would be dense and less dense periods of these particles, which is essentially creating, see, I just can't, I've always been bad with names, but it's really coming up now that I have to learn names. The Fresnel lens, the lens with just the lines in it. So you end up with that kind of lens in the sun's corona, because the particles are not just in random density. They would logically, because of their charge, be in arrangements. And so there might be a more lensing than you would expect, in the sense of more coherent transmission of light, because it's actually creating a Fresnel lens. I think that's the, maybe I got it wrong, but it's something like that. Anyway, so besides that point being raised, he raises points that I've pointed out, and so I just thought I would point them out some more. You have all these gravitational things that we know about out there in space, and one of them he shows in a little clip is this: there's something really heavy and has a few suns that loop around it. And they've known about this thing for like 20 years or something. And they're actually, they actually have pictures from different periods of time, so you can actually see some pattern to the motion. And it's a very heavy object, and it's dark, black. And you'd expect that there had to be something behind it, okay, that's light. It doesn't even have to be much behind it, anything. And it would get lensed because it's perfectly black. And the second argument is that even the suns that are spinning around it end up going behind it, and they should flash. Their light should be magnified every time that happens. And there's no evidence that any of that's happening. So if lensing from gravity was happening, it should be there, and there's no explanation of why it's not. Now, another argument that seems kind of obvious is here you have two pieces of Einstein kind of theory. One of them is the idea of a black hole existing, some mechanism for its reality, which is Einstein's essentially infinite well, where you can sink shit forever and just make gravity stronger and stronger. Where I would argue that because gravity's come from an external pressure, it has a limitation. It isn't infinite. But anyway, it doesn't mean that masses can't get very big under my theory. I don't have to explain it, but even if it's an external pressure, the point is it's kind of like what we're doing. The gravity just goes right through the matter and turns into chemical pressure. We're pushing the chemistry below us, not the physics below us. So the physical thing happens to us, the physical acceleration, and it's just converted into chemical energy going down, which are important distinctions. But from a physical point of view, that chemical energy is the same thing as the physical energy in a conservation sense, which is another holiday comment I want to get to, because he made some sort of vague accusation that something about what I've said is anti-conservational and anti-symmetry, which I couldn't be more pro those two concepts. But anyway, so you have the idea of the black hole. Yeah, sorry, I really got distracted. Einstein wasn't big on the whole. He was on and off on black holes at periods in his talking points. How big they could get. And then you have the idea of this gravitational lensing. So you could almost say that Einstein has to be wrong about one of those, because you'd have to look at the universe and say, especially now, because of this gravitational lensing crap, they're saying there's black holes all over the place. And clearly, one of the signatures of a black hole would be all kinds of these lens flares, all kinds of magnifications of things close to the black hole, so very bright objects, very bright flashes, and clearly anything behind the black hole, especially anything towards, like right in the middle of behind the black hole, would be creating Einstein rings all over the place. So the black hole would have a signature. It wouldn't be black anymore. It would be a ringed object. And because the black hole has such strong gravity, that ring could be very large. The area of space in which lensing could occur could be a very large area of space. So clearly, if black holes exist and lensing is true, can you make any rational argument, any rational defense for those two truths being true? Lensing is real and black holes are real, and yet there's not a single thing in the universe, there's not a single ring, just a ring. nothing, a black hole with a ring, a black hole with a flare, not a single one in all those Hubble images. Come on. So I think just logically you have to deduce that one of those things has to not be true. And I would vote against lensing just because there's even more argument you could make. Okay, it's not only missing in black holes, it's missing on other places where we know there's a lot of mass and a lot of gravity, and yet there's no lensing. There's no flares from other stars, there's no flares from other galaxies. These things that should happen aren't happening. if lensing, if gravity produced this effect as its function, as something it does consistently, there should be more evidence of it. Yeah, in the right places. So, and it's a problem that nobody touches, nobody even goes near it. You don't hear any conversation about the fact that it's missing, and it should be there. That's sort of an important fact, and everybody just kind of, well, no, that's not it. Doesn't mean anything. Well, it's pretty meaningful. It's significant enough that you would think some of the talking heads of science would say, we have a problem and we got to fix that. We got to figure out one way or the other why we're not seeing it where it should be, and why we're seeing it in places it don't belong. Because that's, of course, the other problem. So anyway, I just thought it was useful in terms of this density argument and scatter, and thinking through how scatter could mimic lensing, which seems perfectly possible the more coherent the electrons are arranged. So you end up with the two-slit experiment. If you're essentially creating a diffraction gradient, as I've pointed out in previous videos, diffraction gradients are essentially taking images and projecting them in these other directions. So when you see 5 dots from a laser, or 6 or 12 or whatever, those dots are all just images of the laser projected. And you can sort of see that with a diffraction gradient. When you put it on an actual image made of lights, you'll see the exact copy of the image projected where those dots should be. So in the same location as those dots, you'll see the actual image. So clearly that's a lensing type effect. It's the same mechanism as lensing. And clearly you could have an atmosphere that would be structured, like even our atmosphere is layered. And I mean atmosphere, I'm saying it in the loose term. I'm talking about the fact that there's more than empty space around the sun. There's a whole bunch of energy, ionized particles and such, ionized atoms, and the loose electrons that are probably the main player in photo effects. So yeah, so it's probably enough on that, but it's an interesting revitalization of the lensing subject, because I didn't think he said anything that was completely outrageous. Some of the premises of Thunderbolt's project's videos are kind of just crank science, in the sense they're just using a gimmick argument. I think their argument against black holes is essentially a gimmick argument where they complain about the math having 2 bodies in it, when I've sort of explained that that was the value of Einstein's math, was the very fact that he was accounting for the Earth's gravity effect on the sun, and that the mass of the sun is being moved by the Earth just as the Earth is being moved by the sun. So anyway, yeah, so maybe that's enough on that subject. So maybe I'll do a quick drawing of what I mean by the density argument. So if you have a lot of radiation coming from behind something, a high density, like radio waves or microwaves, it's easier to do that with those things, I would imagine. Where's my black pen? And so say this was the sun, and then you have to I'm just going to put a red line around the sun to acknowledge the fact that it has this atmosphere around it. The idea would be, what they sort of see is that, things very close to the sun, they do get the signal is bent. But things just a tiny bit away from the corona, nothing happens. It's just all dead straight. So you almost get a square waveform. I mean, he sort of has it in the video drawn. He doesn't say much about that, but that's the implication. I said that's the extrapolation I took from it, was it's clear that yes, you have a lensing and then you have nothing. And so it's kind of like this idea. So you have a dense amount of radiation, and there is lensing right at the surface, and then nothing. It's like there's no slow transition of a little bit of lensing, a little bit of lensing, a little bit of lensing. So that's, like I say, he doesn't say it exactly that way in the video, but I think that's the point he's making, is that there's no gradation to the termination of the lensing. It's kind of all or nothing, and that isn't consistent with the laws of gravity, in the sense of the inverse square law doesn't cut it off that quickly. So yeah, all right, and so like I said, this is this is the video. So there's a clip from the movie. So this is the dissident science guy, and yeah, it looks a little like an old woman there. It's not really flattering, but sorry. No offense, dissident science guy. So it's a weird story. Okay, so he made this movie. I guess he started 8 years ago or something, and didn't finish until 2 years ago or something. So it finally got published. And yeah, he's doing a science film that's like a human interest story, because you know, it's like my mother goes to find the truth kind of thing. So that's the theme of the story. And and then I guess the granddaughter or somebody has a baby in some crisis, and the father gets sick and some other crap, and so it has all this life crap into this film that's supposed to be about how Einstein's wrong. And yeah, I just find that a little tacky, or you know, it's not really a science film. It's not a documentary. It's some other kind of entertainment. So I didn't care for that. Just from looking at the trailer, it was just kind of like, yeah, I would really find this a tedious experience to endure. But anyway, but the other weird thing is his mother died, I guess, you know, a year ago or whenever, not too long ago. And so I can see why he's emotionally invested in this project and all that crap. So that's sort of the side backstory thing or something. But yeah, so I mean, I don't know where to put the guy in a category. I don't know yet. He's been doing this for years, and he hasn't, you know, not getting anywhere really. But I like his general tone. But he's also one of these people, like I said, he's really trying to make a community out of cranks. And you know, it just occurs to me, and it's just too Pollyanna in the sense that, I mean, he acknowledges the fact that it's messy. He does that in his last video, I think. And, you know, people are invested in their ideas and all that kind of stuff, but he has this view that all the stories are worth it, or almost. But then he says, you know, he conditionals all his statements, so you can't really pin him on any of this stuff. But there is this kind of idea that somehow good ideas don't stand out, and I think they do. And once they do, they need to be worked on, and you don't need the distraction of a bunch of stuff that is the wrong road. I mean, once you find the road that, oh yeah, this is the doable path, then you pave that one. You know, you don't, you know, and there's a certain logic to that. But anyway, but see, you know, and then the reverse guy left a comment that I just thought was a little bit overstated. So but to see the same rhetoric, you know, and I did see the downvotes on his videos are going up now. Got a couple of videos with 2 downvotes and stuff. So yeah, he's getting a taste of the real world. I think Piro commented on one of his videos, and the stupid cowboy. So yeah, he's just in for a bad day. Anyway, he's gonna wonder what the fuck. What kind of negative energy, wait, did I fall into an evil black hole? Anyway, so you don't want to acknowledge hundreds of experiments and observations over the last 100 years. So it's the same kind of rhetoric. You know, because somebody says the experiments are shitty, that means that you're not acknowledging them, and that somehow there's this huge facts that you're completely whitewashed, or you didn't pay any attention to. And it's just so wrong. But you are willing to believe one guy who worked at NASA on faith. So again, he's assuming that it's not the power of his argument that's persuaded him, that it's just a matter of faith. That merely because he was anti, he said, yes, I'm for that guy because he's anti. And I think that's an unfair criticism, because the guy has made videos pointing out how he doesn't think everything the Thunderbolt Project says makes any sense to him either. So he's obviously not somebody just taking things on faith. All because it supports your ideas, of course. Way to cherry pick. And, you know, you'd almost wonder, I wonder if the reverse guy isn't guilty of the same shit. You know, that he'll support whoever's on his side. You know, I mean, that's a human condition that we're all going to be vulnerable to. You know, is finding allies who are on our side of the fence. I mean, obviously that makes a little bit sense. It's a little hard to find an ally on the wrong side of the fucking fence. You'd think if this was so obvious and enlightening, he might write a paper on it. Well, I guess he did, and it was peer-reviewed. I mean, it's in one of the journals, but it wasn't in the big journal. Okay, so I don't know why that would be true. Maybe he doesn't have enough depth to the argument or something else. But I just think even the superficial depth is depth enough. But maybe there's no underlying theoretical explanation. I mean, maybe it doesn't explain, you know, enough of the mechanics of the corona or something. I don't know what the expectations of journals would be on such a subject. But I mean, it seems worthy of the mere point of raising how many inconsistencies there are in lensing evidence would essentially, in my opinion, be enough of a data sheet that should get some respect from a journal, and maybe they don't. But I have the feeling that never is going to happen. I'll be waiting though. So anyway, so I should post him the link to this half-hour video, 26 minutes. It's pretty good presentation. So I just pointed out, charged particles absorb and readmit photons in new directions. No doubt lots of such particles in the corona. The test might be to analyze how bright the bent image is. If it's dim, that would be reason to think the image was being caused by scatter. And like I said, the only catch to that is, like I said, if the corona is a charged entity, I mean, if it's a bunch of charged particles, I'm just saying you can do the logical induction here and just recognize that there would probably be a bunch of these little tiny lines of density in that field would be a probable circumstance. And that could make scatter more coherent. See, I mean, obviously scatter would be, you know, in a real sense, the photon goes in, hits the electron, and it could go this way, you know, this way, or this way. So obviously it would be only a percentage that would bend all the same way and give you an image. So it would be a much dimmer image, but you'd be able to see it from almost any angle, which would be also interesting. But that would be the implication of just pure scatter, is that you would have stuff going in so many directions that whatever random, all in the same wayers, they would only have 1/10 the intensity of a lensed image, let's say. I'm not sure if lensing's all that efficient either, so I can't say how much light you lose in lensing. But I mean, obviously they're claiming to use it to see things very, very far away by magnifying the intensity. So you would think there's a part of the process of lensing is more efficient than scatter. That would also be a reasonable deduction. So anyway, but yes, you know, you have to really pick at these individual experiments to know whether or not they've accounted completely for the possibility of scatter under what might be slightly nuanced circumstances. That is, just the idea that the field energy you're shining the light through is not randomly positioned. Okay, So where else do I want to go? Yeah, comments. That's it. Yeah. I think we're ready for... Oh, no, I'll do Ken Wheeler while we're up. Yeah, while we're here. Just play some of this, because this is where, you know, it just goes way off the... way off the... What do you call those things? Reservation. It's way off the reservation.
Line that instead of information being transmitted, force, in this case power, is being transmitted. In Hertzian...
So he called it teleforce instead of, you know, he even admitted that Tesla called it his death ray, you know, but he called it teleforce. So teleforce is now scalar waves.
Waves, we have cycles per second, right? And scalar wave technology, i.e. Tesla's true, futuristic, and this is a technology that the U.S. government is already using.
Okay, so we just have claims that will never be backed up with anything called evidence. So, and let's recognize that Tesla spent, you know, the last half of his career essentially ruining his reputation by perpetually and without incessantly claiming that he can transmit electricity through anything. Anything. This doesn't matter. You know, he's going to make the ray gun, and he'll be able to shoot it through anything.
Is instead of cycles per second, we actually have volts per second. This means we can have instantaneous signal transmissions that we had a base on the Mars. Instant signal transmission, and the only thing that is regulated is the voltage.
Okay, so he said it poorly and inarticulately, but clearly he said instantaneous communication. He can send this energy, this movement in the ether, whatever his stick is. He can push on one end of the stick and instantaneously the other end of the stick moves. Even sticks can't do that, right? You know, I mean, if you put a stick from here to Mars, the stick is will not transmit your signal. I mean, it'll crush. It won't accept moving faster than the speed of light. Certainly, it won't even move the speed of your thumb. I mean, it won't do a damn thing of any value. And there's just no evidence provided, just this claim that yes, this magical ability exists out there, and yet there's absolutely nothing indicating that it's out there. Nothing indicating there's some other element of the material universe that's been identified that has some potential to be, I poke it and it pokes on the other side of the universe instantaneously. There's just nothing that indicates that's a realistic possibility. So anyway, you know, it's just a huge, you know, blow up of the credibility. While I'm talking about him, I mean, he's doing a question video, you know, where you can ask questions and he's going to answer them. And it was kind of disappointing because a bunch of idiots, you know, they ask questions like, where are your tattoos from? And, you know, all the camera questions. You're just saying, you know, you should have been, you know, for a guy who thinks he's so smart, you should have been smart enough to say questions about cameras. And then you do questions about me. And then questions about science. But he shouldn't have done all three together, because who the hell wants to do that? I mean, nobody can be interested in all three of those subjects, I don't think. Interested in Ken Wheeler, interested in science, and interested in some insane way in very expensive cameras. I don't think anybody can be interested in that three. Very, very, very expensive cameras. Alright. So enough today. Finished that easy. But, you know, look at this. 171 likes, 11 dislikes. This guy just said instantaneous communication through a Tesla mechanism that'll be able to transmit energy the same way. Like I could just send a big pile of volts to China anytime I want with my Tesla rod. You know. Yeah. And he gets, you know, 20 times more likes than dislikes for saying something that anti-science. And yet people are ragging at me. You know, amazing. I mean, this is the guy that should be thumbing down. Come on, get serious. And if it has to be done, it certainly should be done to people making bold claims and providing no evidence. I mean, not one shred of evidence beyond the fact that Tesla said so. Nothing else. Zero other evidence. And the government has it. But no evidence of how the government has it or has used it or anything. You know. Trump has it now. So Trump has the secret weapon and he hasn't tried to sell it to Russia. Come on. Get serious. Anyway, it's just we live in such a bad place to live. Yes, the world is a bad place to live. Earth is not a good place. They should ban it, or they should at least put up warning signs. Don't make babies. If they have a brain, they're not going to like it. They're not going to thank you for it. Anyway, so some asshole, question mark, is his name. So, yes, just asshole. You couldn't even get past high school physics, and yet you're going to sit here and lecture others about science. Irony much? No, the irony much is that you can't even defeat, in a reasonable argument, providing any evidence whatsoever, making any kind of structured argument about how I'm an imbecile. You can't do that. I mean, you can't beat somebody who couldn't get past high school physics. And you can't even make an argument to them about what they're saying, and instead have to attack them. You have to go after the messenger. You're claiming you're the one who's competent to tell the difference. And again, it's based on such a stupid false premise. If I was in a coma for the first 30 years of my life, what difference would it make? I mean, I failed all of grammar school. Big deal. Do you think that matters? You know, I didn't do anything else with the rest of my life. I didn't work at a machine shop, and I didn't learn a ton of stuff about installing furnaces and you know, electric services and plumbing, electricity, carpentry, roofing. I didn't learn all that stuff? No, yeah, I did, idiot. So the fact that I failed something when I was 15 or 16, what does that have to do with anything? You think that's a good argument? Okay, so you failed the test, not me. Okay, you failed the adult test. You can't think better than that. Then yeah, fuck you. You're stupid. Alright, now the chemistry is a brain hurt. Was. Is obviously, he's talking about chemistry in terms of like doing drugs, I think. Because this is too fucked up. So he leaves two comments there. Him doing some sort of rap or something in text. I don't know. Too fucking weird. I mean, I'd like to leave it, but it's just too fucking weird. So it's got to go. But it's too stupid. So, I won't block him yet, but I mean, that's a sign, right? Just nothing good's going to come my way from that person. Alright, Jay Guan. Okay. I wanted to let you know also that it seems somebody has broken into your house and put some kind of camera device. Oh, okay, it's recording you. No, that's not it. Somebody didn't break in and do it. But anyway, thanks for the info. You should leave links though, yes, just so we know where to go find the people who are doing something. It wouldn't matter though. I mean, what other people do, who cares? I mean, I care, but it's just not my priority. My priority is what I'm doing. So I gotta watch me, not others. I gotta keep myself going. All right. So, Jay Guan again. Enjoy the added visuals with the paper while explaining it. It helps me understand the view you are trying to express. Yes, I like graphics myself. I'd like to do some better ones, and eventually I will. But first, I have to be done drafting the science before I can draft it into performance art. Yeah, so first I draft the script, and then I can perform the script. Yeah, it's that kind of thing. And I'm still drafting the script. I wish I wasn't. Lots of stuff happening. I wanted to get this done in a year. I thought it would happen much quicker. I didn't think it would be this hard to, you know, modify a few facts in the world with what I think is just overwhelming evidence. Circumstantial, yes, but it's just overwhelming that there's a better theory. Alright, so the reverse guy says, LOL, my edit. I know I'm walking on eggshells here. It's kind of a weird statement, walking on eggshells, isn't it? I mean, because obviously they crunch a little, but who would care about walking on eggshells, right? I mean, it's just like eggs. You worry about, oh, I'm crushing the little chickens inside or something. Yeah, I don't know. It's just kind of funny. But yes, we were all very skeptical of each other. True enough. Alright, so then the holiday thing. So go to resonance guy. Just talking some about the thought experiment. Let's see what. But you aim the spot ahead of the hole if you want to shoot through the spot. Okay, so yeah, it's just stuff on the what we've already gone over, the relativity thing with the light clock, which I did have another thought on actually. What the hell was it? Let's see, light clock. Well, I won't find it in time, so hell with it. But yes, it will require in the future. We'll definitely come back to that subject, but for now, that thought experiment is at it's the whole pointing laser thing. Light comes out crooked. How do you prove it came out crooked? Shit. Anyway, Holiday, you make a prediction that light doesn't carry momentum away from a moving body. That's fine, and someday will be testable. Yeah, well, I think it's already testable in other circumstances where I think we do know we're seeing the light from planets and stars from exactly where they were, not where they're going. So there's no velocity being imposed on the photons. They're not moving forward of the object. So that's why we're seeing the object. I mean, kind of by Einstein's theory here, if all this closure is happening and everything's moving forward, we wouldn't be able to see something horizontally when it was going fast, because everything closes up. You make a prediction that light doesn't carry momentum. Okay, right, that's fine. The further implication is that momentum is not actually conserved. Where do you get that from? The further implication is that momentum is not actually conserved. The argument is that photons are already going the speed of light in a direction. They exist in one dimension. They can only have momentum in one direction. And the only thing they interact with are other photons doing exactly the same thing. And all those interactions are kinetic. So where would a photon be able to acquire a momentum from? It's massless in the other two dimensions. It doesn't have any, it only has mass in the dimension it's going. And it's creating your mass right now. Just newsflash. Tons, radiation, is what's creating your three-dimensional body right now. You're pushing out right now. Alright, but the rest of this gets, from what I remember, gets better. But yeah, so I just see it's those kind of statements. You say, where did he get this idea that he can claim I have ever said anything or would ever agree with anything that was anti-conservation? My whole theory is arguing for strict conservation laws. There are no creation forces. There are no virtual anythings. There is no magic thing. Nothing's created from nothing. Something isn't created from nothing, and something never becomes nothing. Alright. Current physics dearly loves the idea that it is by reasons of symmetry. Current physics dearly loves the idea that it is by reasons of symmetry. I don't know what that means either. Current physics dearly loves the idea that it is by reasons of symmetry. Well, I clearly think symmetry is a fact of the function of the universe. Yeah. It doesn't do things with a bias. So symmetry will be the outcome. I watched a video the other day explaining how conservation of angular momentum is extra special curious because of questions raised in an empty universe where you are rotating fast. Yeah, well, empty universe implying what? No gravity? Do arms feel a rising force like a skater spinning on an ice rink would? Well, it's not really a rising force, right? So that's the first thing you can argue is it's only rising because of the connections of the arms. Okay, the force is out. And the only parts that are loose are your arms. So they go out, because they can. But none of the other parts can go out, especially when you're spinning on your feet. Those pieces can't go out. But the idea would be is that the hair can go out, ponytails can go out, lots of other things go out, but not really going up. If you had a ponytail sticking straight up, it would want to go down. So then you would say down, right? Not that that's a particular clever point I'm making. Beyond the fact that, yes, the real point is that it's an out force. And I think it is interesting because it's the whole idea of spin is this collection of energy that can be released any way. Just depends on what hits it, right? Something could be spinning, and if something hits it here, the energy releases it in a different direction than if something hits it here, or something hits it here. Wherever breaks the cycle will create energy in almost any direction. So it's kind of like the orbit thing. The exchange is completely dependent on who's interacting and what they have, what they're carrying. All right, so maybe some pictures on angular momentum. It is an interesting subject. Let me see if he said anything else that needs to be said. Questions raised empty. Okay, I'm curious because of the question raised in an empty universe. Yeah, so it's, that's it. Do the arms feel the rising force like a skater spinning on an ice rink? Yeah, so you have to think that you can add spin when something's spinning, by adding it from any direction. You can spin it on this side, you can push it this way, you can push it this way, as long as you're going in the direction of the spin. But what's happening is your angular momentum is really just it's the out force, right? So in a sense, because from every direction, it's basically saying, I want to go this way, and then I want to go this way, and I want to go this way, and I want to go this way, and I want to go this way. So it's, if you look at it from out here, all these arrows look like they're just, it ends up looking the same as this thing just being like this. These are just radians of outward directionality. And the trick is that there are counter forces that are obliging these things to stay. They can't leave. Like your arms can't leave. They can go out, but they can't leave. And so the spin speed is just a reflection of the arc speed, whatever you want to call this, the length of the path. So obviously when it's inside it goes faster, and when it's outside it goes slower because these distances are so greatly different. This distance and this distance are a huge difference in distance, so obviously velocity changes because the time is the same. Well, time is what you're changing, but I just mean you're changing the speed, but I just mean the only thing you have to change is the time. But there's obviously some force the chemical forces, the bonds between the atoms, but there has to be some force that holds the thing together. So if I spin water on a stick, put a drop of water on, I spin the stick, well, the water just flies to pieces. So it just depends on what the matter is that's stuck to the stick. So when it's spinning, it's all about the stickiness of the bits. But the rotation can be seen as just being that way, just going out, the pressure. And it's just because it's all stuck together that it can't go out. So it pushes the envelope, it goes out as far as it expands as far as the physical tolerances, and that's what it's stuck with. But yeah, so I don't know if there's much to say about it beyond the fact that obviously it's a way of storing energy, spin. So that makes it interesting, and there's all these conversations about because it's movement of mass, and movement requires force to push it. So that's sort of what I'm arguing, that to have that spin, there has to be a bunch of force inside rotating the bits, making them want to go out, pushing them in a direction, giving them velocity. Yeah, but it always has to be a kind of force. So that any battery you create is always just a collection of the stuff that actually moves the electrons, which is the river of force. The river of force is what's getting trapped, collected, stored in this circular motion. Yeah, so I've sort of been over that whole circle thing being important, so I don't think we need to go over that anymore. But anyway, angular momentum, it's just such an interesting subject, spin, in all different kinds of contexts. Saw where that Veritasium guy or somebody did it, I don't know. Well, some Australian guys did it. They shoot the longest basketball shot or something by dropping a basketball off a dam into a hoop. And simply by just spinning the ball just a little tiny bit before they dropped it, the ball went like a mile. Just like a frisbee. It just kept sailing, through the atmosphere, because of the fact that it was bending the atmosphere, curling into it, sticking to it, collecting it. Hard to say that. But it wasn't really interesting. I don't have the link, but blah, blah, blah. It was entertaining to see. But you wouldn't expect just a tiny rotation would have created such a dramatic effect. I mean, the ball went down and it just, almost went sideways, But yes, that's spin in a medium, which is obviously a lot different than spin as a closed system dynamic, what's happening to the stuff that's actually spinning. So it's one of those subjects like waves where spin gets complicated because the form of the thing you're calling a wave, for example, radio wave versus ocean wave or something else, they're really not the same form, and the fundamental structure is the frequency in the radio wave, and in the water it's more about this perturbation in the medium. And with this spinning ball, like I said, the spin was a tiny component. The atmosphere was the big player. So it's more of an ether argument about what happens in an ether than it is an argument about what spin does. That was probably longer than I want to do this. So Robbie Josephson. Blinded by the class dissident Libites and such. I really don't understand your comments much. Rest in peace, first in Mendham. I don't know what that means either. So, let's say thanks, but no thanks. Maybe some other day. Alright, so the other subject was brought up again by the reverse guy. Yeah, so the dissident science guy is a fan of this, the idea that the Earth got bigger, and that caused the, like, you can put all the continents together, and if you shrink it all in, you can make the Earth into one solid out of the continents, so they fit into a smaller sphere. And there's probably a certain inevitability to that, just as in the argument that if there was ever one continent on a sphere, so you could say the same thing would be true if you had one blob of land on a sphere and it didn't cover the whole sphere. Like even if the sphere was huge and the continent was fairly small, and then you broke it on a sphere, there's probably some logic to the fact that on any spherical object it will do exactly the same thing. So no matter how big you make the sphere or how small you make it, it would do exactly the same thing because it's on a sphere. And so the same tensions would exist. There would always be a slope. And it really doesn't matter how big the slope is. I mean, the bigger the faster, but the bigger not the more. So I think it's fundamentally defeatable just as a thought process that, well, that would be inevitable. If I broke anything on a sphere, if I shattered something on the top of it, a coating on a sphere, it's always going to shatter the same way, no matter what size the sphere is. It's going to tend to be very close. Let's at least say that. The pattern would be quite similar, if I could say it that way. So that's one defeat. Just logically saying, don't get fooled by, something too obvious. But then when you go into all the logical arguments, I haven't heard their excuse for why the Earth is getting more massive. And they use dinosaurs as an example by saying the Earth had less gravity. And so that's why there were dinosaurs that were so big, is because the Earth had less gravity. And that all sounds all fun, but we already know that they can be explained just because they did have physical structure. They were very bulky, and there would have been dinosaurs that were really big and thin if there was less gravity. They wouldn't have had big fat legs and all that crap. So I think that argument can be defeated pretty easily. But there's just so many arguments. I mean, the evolution of birds would have never happened properly, let's say, and but what about the moon? So, I mean, if the Earth was substantially smaller, I mean, these people are talking like the Earth is expanding by 6 feet per year. Oh, no, per your lifetime. So, per 100 years, 6 feet in 100 years. It's a lot. It's a lot of mass to gain. And, but yeah, what about it just doesn't make any sense, because what about the moon? Yeah, I mean, we wouldn't have been able to, the moon couldn't have been as close, quite obviously, if it was smaller Earth. So it just doesn't really make any sense, because the moon wouldn't have been capturable, in a sense, by such a small planet. It would have got captured by Mars or some other kind of thing. When Mars moved close, the moon would have said, "Screw you, little tiny Earth. I'm going with I'm going to play with the big boys," something like that. So it doesn't make much sense. Just in a very superficial look at it, you say this is kind of a flat earthy kind of thing. I mean, it's better than flat Earth in that the graphic is, it does get to you a little bit. You just see the continents. They simulate it, and you just see all the continents just twist into a little ball. You say, okay, yeah, that's, wow. Yeah, it fits. But, yeah, that's superficial science, right? I mean, you can't be fooled by stuff that's too obvious. Well, you should just know that's probably for a reason. And there probably is a reason. And so, but that's the thing. I can't tell how honest this guy does his research. I can't. Maybe nobody's counter-argued to him, which I doubt. So he's probably heard counter-arguments, and he's just not, he's not conceding that the counter arguments explain this stuff, and so he's not tempering his enthusiasm for it. Because this is another thing where it's like more than 10 years, maybe longer, 15 years, he's been thinking this. And you're saying, that's a long time that you haven't heard all the arguments explaining why this can't possibly be true. I mean, like I said, I haven't gone into it at all. Spent a half hour on the subject, thinking about it. But you just go through all the things about all the geology, the fossil evidences, all the other stuff that would, be implicated by the Earth being that small and having expanded that much. Yeah, I mean, I don't even think you could. Well, I don't know. Yeah, so, I mean, you have to go through all the islands and which ones were continental, hunks of a continent, and which islands are just the new ones being made by volcanoes, and so it all gets a little complicated. But I'm sure there's good evidence when you find fossils on I mean, you'll find that. Well, that really won't tell you anything. So, okay. See, I'm thinking about it now, and I just really. But there's probably plenty of people who've done debunking research, so I guess I don't need to do it. But yeah, so it's just another strike against credibility, because you can't, if you just keep making a simple argument and you don't go into some of the details, you just kind of show them that you're kind of afraid of the subject. So that would be my general impression. Alright, well, I'm getting a bit tired, so we'll call it a day. I don't think there's anything new or interesting to deal with. Hatha did make a last video on the, light clock thing. Short video. I haven't watched it, so no offense. I'm sort of just done for now. So I'll move on, and I think maybe not, but I mean, it's just still rolling in my head. Once you get the subject in your head, you just keep playing with that subject, unfortunately, when you don't want to. Yeah, it's just something happening with my brain when I go to sleep. I was saying in another video how I had these fucking, it's like seaweed with heads on it, like manta rays or something, trying to bite me. And it's like my brain is just coming up with all these horrible images lately. And they're not dreams, they're just like before you go to sleep kind of things. It's like, you're saying, why, like shit coming out of a horse's ass or something, because somebody said horse's ass or something, and my brain uses that, and all of a sudden I'm seeing shit coming out of asses, and it's like, what the hell? Oh! I close my eyes. It was just bizarre, because I never had that happen, where my brain would just go off in completely random nonsense. I was always pretty good at seeding my thoughts and keeping